Oh, I'm excited to tell you about it. So I don't know if you've heard about YARP before, but it's a fairly interesting new project that came out of Microsoft recently. And YARP stands for Yet Another Reverse Proxy. They essentially built a toolkit for creating your own reverse proxies. And this is somewhat in contrast to the traditional approach of taking more appliance-based projects and just tweaking them through configuration. And this really appealed to the geek in me because I'm always like down in the code, decompiling stuff, trying to manipulate things. This really gave me a really interesting toolbox to shape how traffic gets into my apps and really make really cool things about it. So after I started playing with it and actually I started contributing to the project, I realized there's a tremendous opportunity to use this to shape different security constructs. And I've been able to apply some of those constructs with some of my clients to really simplify how they do securities for their applications, which I'm super excited to share with you guys today. So let me share my screen for a sec. There we go. So
there we are.
There we go. So if you go to Microsoft GitHub.io reverse proxy, you can find all the cool documentation on what YARP is all about, right? It's kind of weird if you go into articles, which is really where you find the true documentation for what it is. But I want to maybe go over today with a hypothetical scenario. So I've actually built an application that represents some baseline security requirements. And we're going to show you how YARP can be used to satisfy those requirements. So I just go over the architecture. What I've actually built is a weather application. So not super exciting. We've seen it as a standard .NET template when you create a web API. But this one is a little more elaborate. I'm, by the way, an aviation geek. I have a pilot license. So
very cool.
I figure, hey, can I integrate some of that passion into this app?
And I see the Blazor logo there, so I'm immediately a fan of what you're doing.
You know what? This was my very first foray into Blazor. I try to stay more on the backend side, so I'm like, I gotta build something sexy. By the way, Layla really disagrees that this app is sexy. So from a architecture perspective, this app has a simple front end and two backends. We have a weather service that serves up weather based on the location ID. And these are airport codes mainly, where the report was taken. And then the other one is a geo service. And the geo service is kind of cool because I'm using a geospatial library to figure out where the closest station is based on the XY coordinates your browser sends for your actual physical location, right? The source of the data is actually dynamically downloaded from an aviation weather site. This is a government-run website that publishes these XML dumps of really aviation weather from all over the world. And what I wanted to kind of create is a scenario where a business came to you and said, look, we have this app and we would like to do a few things. First, we want to allow the users to authenticate against a centralized identity provider. This identity provider doesn't going to give you a hell of a lot, only the username of the user. But for this specific app, we also need to make sure that we display extra weather information if the user is paid for it, right? So maybe they're paying for a premium weather plan. So how do we get those extra rules and claims about the user combined with a public identity? We also want to block off access to backend APIs from frontend. And we want to provide a logout and automatically expire session due to inactivity. And
as you outline here, like we're paying for some of this data, so we don't want random people like hitting our APIs in the back end and costing us money.
Exactly. So some of the API calls are actually what's considered bulk APIs, and I really don't want to expose bulk APIs because they're heavy to just anybody's. So from that perspective, this is what we're trying to accomplish. Now, there's a few challenges with doing this, and I've actually seen my own customers trying to solve this exact same problem. And the very first one that is very commonly encountered is when you authenticate against a common identity store, whether it be like Active Directory, maybe Google. Most of the time you get just the username and maybe an email. But most applications will have very line of business specific authorization requirements, whether it be rules, whether it be scopes, but something very specific to that app. And that's usually not managed at an enterprise scale. That's usually very specific to that app, and they'll build their own set of tables to kind of manage that information. The challenge is, how do you efficiently combine that upstream login information with the local line of business authorization policies, because the token that we received is actually immutable. It's signed. We can't actually go and stuff additional claims that we can now assert on. And this is a common struggle for teams. So we need some kind of enrichment logic that needs to happen. And what I've seen a lot of teams try to do is make that enrichment happen on every single call and place it in every single microservice. So you get this fairly elaborate, complicated piece of logic that gets duplicated all around. And what that creates is complexity. It creates complexity that often teams are not well equipped to handle. Like maybe you'll have one guy on a team that's strong with security, but most developers are kind of very good at writing line of business code, not modeling security. We also have a problem of like those tokens expiring, and we need a way to refresh it. So what I'm actually going to show you guys today is how to use a gateway pattern to solve this problem. What we're going to do is put a gateway right in the middle of everything, and we're going to connect this gateway to the identity provider. In this case, I'm using a mock development server based on an identity server project to authenticate it, but it can be connected to anything. Google, ADFS, whatever. The gateway is gonna expose the API endpoints to the front end, but some of those API endpoints will have authorization policies applied to them. So unless the front end is authenticated, the gateway will automatically force a redirection to the identity provider to log in. And then after the login happens, what we're going to do is establish a cookie. So we're actually going to stuff all the claims about who the user is, what they're allowed to do into a session principal cookie, and issue it to the front end. So anytime the front end talks to the gateway, that cookie can, all the information we have in it can be extracted, and the principal rematerialized. Now, what gets sort of interesting, and not a lot of people I've seen attempt to do this, is actually send that principal to the backend services as a job. So it's a very common pattern to use a cookie between the front end and like the gateway. But the best way to actually propagate the identity of the caller to the backend, or the simplest, is through a JOT token. Most will try to pass in the original JOT token that they got from the identity provider. But what I've actually found is if we make the gateway itself the issuer of said tokens, we now have the opportunity to enrich them, right? So we can actually get that, oh, I'm Andrew, and Andrew is also a paid user, stuff all of that information into a JOT token, and send it to downstream app. Does that make sense?
So, yeah. So I've heard the term backend for front end. How is the gateway different? Is this something similar?
That's a great question. So there's a bit of an overlap. So API gateways are primarily focused on exposing APIs for generic consumption, right? So we build APIs and we usually make them structured around business domain constructs. And that allows us to recombine them and create new wonderful things. Backend for front end is also a set of APIs, but those APIs are primarily tailored for serving just very specific GUI interface. So this is very powerful concept when you start thinking about single page applications like Blazor, Angular. They primarily interact with the server side through a set of REST calls. But if we try to use standard API calls that are generic, you'll often find that they're highly inefficient. There'll be a lot of extra data. We may have to do a lot of one-off calls. So the backend for front end really allows us to shape and optimize the API pattern for the app, but it still follows the single API surface that API gateways provide. From a security side, there's also differences because oftentimes interaction with a true API gateway is done either through bearer tokens, JOT tokens that we send along the way. But when we talk about supporting browser-based applications like a weather app here, we usually establish a session cookie to facilitate things like sliding expirations, so we can automatically renew things. It also makes it easier for handling requests that are automatically sent with the browser, because the browser will automatically include those cookies and allow us to not have to deal with attaching those requests manually. There's pros and cons to using session-based authentication. And when I say session-based, I really mean cookie-based versus bearer tokens. Primarily because the browser includes them automatically, you have to be a lot more careful around how you structure your course policies, because an external site might take an advantage of that and send a request to one of the backend services, hijacking your logged in session and doing malicious things around it. So there are ways to mitigate that using course policies, but we're not going to get too deeply into that today. So you ready to look at some code today?
Yeah, let's do it. Let's dig in.
All right. So what I have is the set project already coded. I do have the gateway already built, but we're going to actually go and build one from scratch. And I'm going to show you how to introduce YARP to your project and then add the security constructs that we've been talking about. So the first thing you're going to do is create a new web application. In this case, I'm going to use a web API, and for now, we're not going to do any auth. So we're not going to need any of the out-of-the-box models. I'm going to delete the controllers. I also tend to delete the IIS profile settings because I run all of my stuff outside of IIS, and it just tends to muddy the waters. And I want to make this one run on 9090 because all the other apps are kind of expected to communicate to the API gateway running on 9090. We're gonna now need a few dependencies. So personally, I'm not a huge fan of using app settings JSON because JSON is kind of difficult to use for configuration, and later on we need to put some configuration values that make it very difficult to encode in JSON. So in this case, I'm just going to install a YAML configuration provider to allow us to essentially create an equivalent of app settings YAML. The next thing we're going to do is actually add YARP. So this is YARP.reverse proxy.
Something that's just up on NuGet we can grab.
Yep, it's all up on NuGet, and it's now GA 1.0. And finally, we are going to need identity server. So I'm going to use identity server 4. Now, this dependency may look weird to you. You're like, why are we adding identity server 4? Because it's a full-featured identity server, blah, blah, blah. We're not using it as identity server. We're using a subset of the classes found inside this particular NuGet package to do two things. It simplifies issuing JOT tokens from a claim principal. And number two, it exposes a discovery endpoint. So if you worked with OpenID Connect, one of the go ahead.
If you can zoom in just a little bit on the code there too, just make that a little bit bigger.
Is that good?
Yeah, I think that's better.
All right. So one of the things that we are going to need, if we look at this diagram, if we're going to be sending JOT principal to the backend here, is a way of signing those JOT tokens. And in this case, what we're going to do is actually give the gateway a signing key. It's basically going to be a PEM certificate file. But the backend services need the public key portion of that in order to validate that the JOT is truly coming from the gateway. Now, one way is to actually copy the public key into each microservice. But the OpenID Connect gives us a really easy way of bypassing that step. And that's through a discovery endpoint. Are you familiar with how that works?
No.
All right. So I'm going to show you real quick how the discovery endpoints work. I'm just going to spin up the identity server here.
While you do that, identity server, what was the whole licensing concern people were having when they like updated the last version of .NET?
Oh, right. So the identity server past version 5 has moved towards a paid model. So if you're a company over a certain size, you have to pay for a license. And that's unfortunately made it a non-starter for certain organizations because of procurement issues or whatever. Management doesn't want to pay for it. So in what we're showing today, even though Identity Server 4 is used, it is used as a helper library. I'm using Identity Server 4, which is free. And the features that I'm using from it are actually very minor, so you can easily replicate them without using Identity Server 4. I'm just using them for the purpose of brevity in today's demo. So if you go to any OpenID server, they will have this URL called .well-known OpenID configuration. And this is a standard URL that services that received a JOT token can go to and basically say, oh, look, there is a signing key published right here. And this is essentially a way for them to dynamically download public key for the JOT token that they received and confirm that they're actually received the valid JOT token. So let's keep going. So we have this. Where did we leave off? So we added dependencies. Now we need to add YARP. So first we're going to do is add app use map reverse proxy. And we need to now add some stuff to the dependency injection. So for this, we are going to use builder load from config. So it's going to load all the configuration from reverse proxy section of our config. And since I said that I'm not a fan of JSON, we're going to register YAML file.
I love how .NET Core 6 is like so simplified right here in your config or your program CS. Like it's all just configuration.add, services.add, use this. It's a nice pipeline that they've set up here.
Oh, absolutely. And I'm actually a huge fan of the new program CS file, which kind of deprecated the use of a startup file. I actually think that's a really good thing. So now that we have app settings YAML, let's look at how to configure YARP. So the first thing we need to do is define clusters. We basically said we need top level config key called reverse proxy. And under reverse proxy, you have two main configuration sections. First one defines destinations where traffic can be forwarded to. And destinations are grouped into clusters, right? So we have two destinations. We have a geo service and we have a weather service. Under each one, you can have more than one instance of that service. And this is really useful if you want to apply YARP as a load balancing type tool, because you can have, let's say in a Kubernetes without a load balancer, you can actually say, send traffic to this pod and this pod and this pod, and reverse proxy can actually do that. In fact, YARP right now is going the development to add true support to act as a Kubernetes ingress controller. So that's pretty exciting. I'm actually contributing code to that one. So now that we have clusters defined, the next thing to do is to define some routes. Under routes, we are going to say the route name is going to be GeoService. It's going to forward traffic to the GeoService cluster. And it's going to do that when we match any request that has this pattern. So API station closest, because that's the only API call that service actually exposes. The other thing we're going to do is actually strip the API section of the call before forwarding the request, because the GeoService itself only responds to /station/closest, but on the API gateway, we want to have this prefix, right? But we need to strip it before we forward the request downstream. And the transforms is actually really powerful because it lets you really shape how the request will look like before this forward. This is where we have the ability to like add headers, remove headers, manipulate the request in multitude of ways. Let's now add the other one, which is the weather service. So we have this, and you can see that I'm using a wildcard. So basically, anything that didn't match this pattern is gonna fall into this block and work off that. So let's try it. I think that's all we need. I'm gonna start my 2 services. By the way, this is one of the main reasons why I switched to using Writer. The ability to launch and stop things independently in a large solution is really something I feel Visual Studio can improve on.
Yeah, I made note of that in chat that you're using Writer. It's nice to see a different IDE for a change. I was not aware of this feature. I like this.
All right, so we got the YARP launching. So let's try this. API station closest. Since we didn't any pass parameters, it basically gives us the closest airport to 00. So that routed to the GeoService API. And I know that there's another one for like a /diag endpoint that is exposed by the weather service API. And this one is really meant to echo the request that came in, right? So in this case, this is what the YARP forwarded to the application. Let's get rid of this cookie because it really doesn't belong on the backend. And so you can see that I've used the transform here, but you can also add them programmatically, right? So I'm going to go in the backend here and basically say add transforms, context, and that will basically apply this to transform to any request. So I don't have to define it for every route in my config file. In this case, we're stripping cookie from the downstream request. Okay, so that's done. Now let's actually start adding security. So the first thing we want to do is connect our gateway to the identity provider. And the way you do that is just using standard ASP.NET OpenID middleware. I'm going to copy a block in here for the sake of time, but we can look at it together. So in this case, I'm basically saying that we're going to use authentication. The default authentication scheme is going to be cookie. But the challenge theme, like when you're not presenting a valid cookie, we're going to basically challenge you using OpenID. And that's the one you're going to be logged in with. And at this point, we're configuring the settings for the OpenID Connect. So we're saying that our identity server is running on this address. This is a client ID and secret we're going to be using. The code is how we're going to do the token exchange. We only want the OpenID and profile scopes. And just for the sake of information, we're going to put the token that we receive from the identity server into the logs. Definitely do not have something like this inside your real code because it's not a good idea to put tokens inside your logs. So now that we have that, we should be able to slap on some authentication. Let's add one more route for that diagnostic endpoint I was showing you earlier. So I'm going to add weather service diag. We're going to map it to just /diag without the API. But you'll notice I've set this authorization policy equals default. This one is predefined in YARP and basically says that you must be logged in. If you want more elaborate authorization rules, you can use the standard ASP.NET authorization to set that up. So let's restart this and see what we end up with.
That was our before.
Sorry?
That's our before.
Yeah.
Before any of the shaping takes place.
But now if I access the /diag, what happens? I missed something. I believe I need to do add use authentication. Yeah, I need authentication middleware here in order to work properly. Let's restart this one more time. And to demonstrate this better, I'm going to do an incognito window because I already had a session cookie, it seems. So now I'm trying to access this endpoint. Is it working? Aha, here we go. So it redirected me to the login screen. You can see that it didn't actually let me access that endpoint. You said you have to be logged in first. I'm using a development identity server, which is really good for, when you want to rapidly work with stuff. And I highly encourage viewers to develop something like this for themselves because it speeds up how much you have to do, especially not having to put in username and password or deal with any 2FA stuff that a real identity provider that your organization is forcing you to use. And this is just to speed up that inner loop cycle. So in this case, I'm just going to click on Andrew to log myself in. And voila, we're logged in, right? So I can now keep hitting this endpoint, and it's allowing me to do that. We can see that there is a cookie that has been established. And this is the one that is currently containing that serialized principal that allows me to do all this.
Just want to give you a little time check as well. We got 20 minutes left.
Awesome. So that's the easy way to forward to secure endpoint. Now, let's take a look at the next step. I'm going to switch over to the completed version because there's not that much left to do. One of the things we want to add is the identity server bits in order to do the JOT token signing. You can see that even though the request was forwarded downstream, we don't have the authorization header. So in the diagnostic endpoint does not receive any claims because we secured that endpoint, but we haven't actually propagated the identity downstream. And in this case, we need that identity downstream. So how do we do that? We need to issue that JOT token and we need to attach it to an outgoing request. So in this case, I'm going to add the identity server bits for the issuing and for publishing that OIDC endpoint, the discovery endpoint I showed you earlier, but now embedded right in the gateway. One of the things that I've custom implemented is this signing key credential provider. And this is the thing that basically dictates how the issued tokens will be signed and which key is going to be published on that special endpoint. And in this case, what we're going to be doing is just reading the signing key as a PEM from the app settings. So if I go here and look, I have a signing key in YAML. And by the way, this is why I chose YAML, because if you try doing something,
I was going to say, it makes sense now.
You will rip your hair out. I like my hair. Right, so we're just importing that PEM file into an RSA signing key and just serving it for these two interfaces that are part of Identity Server 4. The next thing that we want to do is build a custom transformer. So I've showed you earlier how we have the remove path transformer that we've specified through config, and there's another transformer that we use for cookie. What we want to do is build a custom one that allows us to take the current principal and serialize it as a JOT and attach it as an extra header to be sent downstream, right? So we have a JOT principal appender, and it's really quite simple, right? So we're basically just taking the current HTTP context user, and if the user is authenticated, we are just transforming. We're doing a minor transformation because that claim set will have a name identifier. We're switching it to a name. It's just a very small transform that is technically not even needed. And at that point, we're just using this one call to convert the principal into a JOT string. And we attach it to an outgoing request as a bearer token. Does that make sense? And then inside our program file, we're just registering to do this for any request. So any requests sent downstream, if the user is authenticated, take their current principal and send it downstream as a JOT token. That's pretty much it for that. Let's try to run the real gateway now that has this code. I'm going to start a new incognito window so we can see it from the start. Post. Voila. So we logged in, and there is our token that was sent downstream. Now, you can see that the downstream service has successfully processed this token because I'm actually echoing things from the claim set, and you can see that it knows that I'm Andrew and that I'm actually a premium user. Now, one thing we haven't talked about is how did this get in here? How did we get this extra claim? And that's an important piece, the one I mentioned in the beginning people are struggling with, like how do I enrich it? Because this token was issued by a gateway, just for sake of illustration, I'm going to go to this gwt.io site that lets you kind of visualize what's inside a token. We can see that the issuer of the token is localhost 9090, which is our gateway. It's not the identity server that we've actually logged in with. Oops, sorry. This extra claim was actually appended by the gateway itself when the user was first authenticated. And the way that happens is through this claims transformer class. This is actually a really interesting interface that most developers are probably not familiar with. But what it allows you to do is take an incoming principal and shape it in some way or form before the rest of the application starts running. So right after we've finished all the authentication process, we get a chance to reshape what the current logged in identity looks like. And in this case, I'm using obviously a very ugly hack. I'm basically like it's hard coded saying that if I'm Andrew, then it's a premium user. In a real world application, you'll probably query a database or some kind of repository to figure this out. But in this case, you can see that I'm actually creating a new claim and then replacing the principal that came in with the one that contains this extra claim. The way you use this class is by simply registering it inside your DI container. So by just adding it to your DI container, your ASP.NET will automatically pick this up and invoke this code in order to reshape your principal, and that lets you enrich it. So again, we logged in, we got this incoming principal from the OpenID Connect that basically identified as Andrew. We ran it through the transformer to add an additional principal into our claim set, and we issued a token back to the user in the form of a session cookie, and for the backend, we sent it as a JOT token. Right. So let's maybe look at the whole thing end-to-end in action.
Yeah, that's interesting. I didn't know that the iClaims transformation was there. That's it's clever how the framework just picks it up and uses it too through dependency injection.
Yeah, and I haven't found a lot of info on it. Like it's just one of those things that exists, but it's like you have to know about it to find it. Did we shut down it? Oh, that's kind of weird. It is running. All right, so let's try the actual app now. So we're gonna go to 8080. I'm already logged down because I have a session cookie. Let's just restart that. So in this case, I'm accessing the app anonymously. You can see that I'm getting some info. So it's still able to process. I have, oh, it's apparently warm outside. It was like 0 last night. 62 if you're American. But you can see that these values right here are empty right now. And that is because my downstream service is actually requires, we're not securing just the endpoint, we're securing data, right? So if we look at the logic here, get forecasts, we have an if statement here saying that if it's a premium user, only then will you set the clouds, relative humidity, and wind speed. So in this case, it's very important that we propagate that security context to the backend, because what I find a lot of people over-focus on is securing endpoints, but securing data is very important, and selectively trimming what the user sees. So this let's us demonstrate how that works. So now let's log in. In this case, we're going to log in as Andrew.
Is this code up on your GitHub page, Andrew?
Yes, it is. So there we go. And now we see this stuff here. The really nice thing about this code is because the data is free, unlike most other APIs out there that require you to sign up and get an API key and stuff like that. You can just clone this and it will work. Like there's no special configuration needed. And as far as I'm concerned, this is actually a real weather app that can work for anything in the world. I think that's pretty much covers the basics. What do you think? Was that kind of easy?
Yeah. So this is really interesting. And I guess from a question for me, if you can go back to like one of the original slides, if you have multiple front ends, can you connect, say, like a companion, like mobile app to the same gateway? Do you need something else there? How would that work?
It really depends how you do it. So the true BFF pattern basically says you build an API specifically to your front end. In this case, I didn't go full on BFF pattern where I reshape, where I optimize the API calls specific for this app. I primarily focused on the BFF from a security perspective, right? So we have security requirements that but if we wanted to shape the data, yes, you would probably create specific API calls, API endpoints either directly inside the gateway or create a dedicated BFF service behind it. I would actually recommend placing them directly in the gateway and then using that to retrieve the stuff in the backend. For a lot of applications, you will not have to reshape every call. You might only want to reshape some calls and then forward others as is to downstream. In this case, we only have this single front end. And in fact, right now, the weather app sits as its own application. If you have a single page app, I actually recommend that you embed it directly inside the gateway. So the gateway itself, like, with a Blazor, for example, you can have an ASP.NET host serving up Blazor application itself. So in this case, you can actually combine it and place it, the Blazor, basically use the gateway as the host for serving the Blazor app. I'm not doing it in this project, but the advantage of that is the weather app and the gateway now share the same URL. And in this case, the weather app can basically call itself wherever it runs on just /API and off it goes. And the gateway automatically adapts to how that traffic flows to the backend. Overall, I think YARP presents a really cool way for us to slice and dice and simplify security in a way where complexity is pushed away from the edges, where your rank and file developers tend to spend most of their time, and into the middle where few specialists can go and kind of configure it properly and maintain it and set easy to use ways for developers to do it. It's also mobile. So this gateway is not tied to any specific infrastructure. So it's infrastructure agnostic, it's free. And I have a lot of control to both shape how the traffic is ingested and the kind of security policies that are applied to it. This code is up on GitHub, so it's sitting on YARP Security Workshop. One thing I wanted to briefly touch on is a sister project that I've kind of maintaining, and this one is what I consider of production quality, because I actually have a customer using this in production right now. So it's not specific to OAuth, but what it does solve, it applies very, very similar pattern. but deals with Kerberos authentication. And this is something that a lot of customers are struggling with, coming from Windows environments where they use integrated Windows auth a lot, and then are trying to migrate into the cloud in containers, and they're finding that it's actually really awkward to work with Kerberos in those environments. So this particular project allows you to have the caller talk to the proxy using Kerberos, but then the proxy talking to the backend is all JWT. So that lets you actually isolate the it lets you isolate the backend services from what many consider a legacy security protocol, and simplify your deployments. What I haven't showed in the other app, and this is a pattern that's really powerful that you can extend with, is the reuse of the JWT tokens that were sent downstream to continue chain the call. So let's say we have a caller that issued an API call to app1 through the gateway, but now the app1 needs to call app2 to finish processing that request, right? So in this case, the app1 doesn't talk to app2 directly, it talks through it through the gateway, but the way it authenticates to the gateway is using the same bearer token that it received through the proxy. That bearer token, the one that we generated as part of the original request, is very short-lived. It's only good for 1 minute. But the proxy is now able to accept that same token and say, hey, yeah, you're welcome back. I issued you that token. I know who you are. You're actually app1, and you're trying to talk to app2. I'm going to let you do that on behalf of this user, because it basically has the information about the fact that this token was issued for app1, and it carries the original caller information. This really simplifies the what the edges have to do in terms of token management, because the tokens now don't need to be cached. They don't have to be secured. They can be used one time and discarded, and that's also part of the benefit, right? The fact that they're short-lived, they expire very quickly. Even if they leak, it's usually not a big deal. And your developers are super happy, because on the services side, the only thing they have to do is add standard JWT bearer middleware and point the authority to the gateway. So this setting right now actually points to the gateway. That's how it scrapes the signing key. After that, they can just start using the standard assertion policies on their endpoints and inside code.
Yeah, this is again, something I don't normally deal with. I spend a lot of time on the front end, maybe some time in the back end, but security is definitely one of my weak points. So it's been a very interesting session. And if we could, let's bring up those closing slides again and share the links one more time for folks.